starting off with, this is a 2012 Yukon Denali we're going to be using in this example. And we're going to find that this vehicle has an engine cold air intake that's been installed onto it. So we need to do a MAF recalibration process. It's actually really, really easy. And we're going to be using our VCM scanner to tell us what changes we need to make, then move back into our VCM editor side of things and make those changes. And I'll go through the process of tuning the idle and part throttle for the mass airflow sensor curve. So I did a read on the vehicle. This is going to be the original file that I've read out of this particular vehicle. We jump in here to engine. We go in here to air general. We can see the MAF calibration, airflow versus frequency. This will be the stock MAF calibration curve that we are going to be working with. And if we jump in here, we can take a look that it's a nice, smooth, progressive line here. And this is going to be the stock calibration, again, from GM. So we've installed this intake. That's going to be throwing off the calibration just a little bit. So we need to go back in and clean things up. So let's close this. Let's jump into our VCM scanner. So jumping in here to our scanner, we're going to find here that we need to go and read the vehicle. Now, we did this already when we took a look at our closed loop trims. And in fact, here on my scanner, it's recognizing this as a 2012 GMC Yukon Denali. However, we're going to want to do this again so we can generate a custom channels list for this vehicle. So year, make, and model is going to be very specific, and we can see a lot of what we're logging in here are SAE channels. Now, we did add in the closed loop video our wideband and the commanded air fuel. We're going to be using these to guide us in doing some of our tuning here. I'm going to be showing you that. Specifically, we're going to be taking a look at our O2 switching voltages versus our airflow in pound per minute, making sure that our air fuel, when we're driving part throttle, is going to be targeting where we want it to be at. Now, we talked about that in that last video for closed loop operation. We're going to take a little bit more specific look at it here. It's going to be part of doing the mass airflow calibration. We don't have to do it. We can skip it, but it's going to be making sure that when our closed loop trims are applying the short and long-term trims and focusing around that target of 14.5, 14.7 air fuel at idle and part throttle, that our wideband is going to be showing us and backing that up. If we see that our wideband is different, we may have to go in and change our switching voltages. So I'll walk you through that, as well as taking a look at the mass airflow calibration process, which is super, super simple. So what we need to do right now is go here and connect to our vehicle. We need to make sure we generate our custom PID list, or the channels list, for this vehicle, because we're going to be adding things that aren't this SAE default parameters. So what I'm going to do right now, I'm going to be clicking in here. We can see we have mass airflow selected right here. That's going to give us our pound per minute reading. We need to log what the frequency is from our actual mass airflow sensor, because we're going to be building a custom histogram here, or an overlay chart. That's going to guide us in doing our tuning using the short and long-term fuel trims, as we're going to be finding out. It's actually a really, really simple, again, process. So what I'm going to do, put my cursor right here on mass airflow. I want to put my channel right under this so we can see mass airflow is right here. I'm going to go into my channels list, add channel, and I'm going to be typing here mass, and we're going to be looking here mass airflow sensor frequency. We've already selected mass flow rate. We can see that's in blue. That's going to be that channel here. So anything you see that's been selected in blue is already going to be populated on your channels list. So we're going to go and grab this right now, and we're going to grab this frequency aspect. Now, while we're at it, we can also add our mass airflow sensor state. This is going to be telling us if we're in MAF, failed, or non-failed mode. So we're going to find in most situations, we're going to be driving around, we're going to have MAF not failed. And that's what we want to operate right now. So let's go in here, double click, and we're going to be seeing that's been added right there. So we've added our channels in here, and that's going to allow us now to take a look at things specific to our mass airflow sensor. Now, one thing we have to do before we actually start doing any kind of tuning, we need to jump back into our VCM editor right now, into our stock file. We need to make sure we set our dynamic here, so that's going to be running on our actual mass airflow sensor exclusively. Now, I've already done this, and I wrote it to the vehicle. This was previously at 3,000 RPM or 3,500 RPM for the high RPM disable, and the re-enable here was around 3,450. So it was switching over to the mass airflow sensor at that RPM range. So what I've effectively done, telling it right now that the high RPM disable here is 100, as soon as I start to crank my car, it's going to be switching right over to the mass airflow sensor. This is going to be the only way we can effectively go in and tune the mass airflow sensor. If we don't set our parameters here at 150, we'll be biasing between the speed density calculations for the map sensor and the mass airflow sensor. And we're not going to be able to effectively tune this curve because we're not going to be focusing just on the operation here for map. So we're going to be taking it off the map sensor speed density calculations, putting it on the actual mass airflow sensor, and that's going to be effective again in our dynamic spot here. So we need to make sure we set our parameters to 100 and to 50 and then do the flash, which I've already done in this case. So taking care of that already, we are ready to go and we're ready to start logging this and taking a look. Now the next aspect after we've added our channels here, we're going to go into our graph portion onto our histogram and create a custom chart. It's really simple. So what we'll do here in our white space here in our graph, we're going to right click, we're going to go to graph layouts. We're going to go up here and we're going to go click add graph and add table. We can see it's going to populate a new table right here. We can actually see it's been added. Now we're going to have to add some custom parameters in here. So go into our parameters at the top. We're going to click on this. We're going to move down to the bottom. We're going to go in here to fuel trims under maths. Click on this and we're going to be looking here at our LTFT plus STFT, the long-term fuel trim and short-term fuel trim. It's going to be taking the average of both banks of both trims. So this is going to be effectively putting one percentage correction value into a histogram for us. And it's going to be very useful and we can dial things in very, very quickly. So let's go ahead, we'll double click it and we'll add it right here. We can see the unit scale is going to be in percent. We can see the decimals, we'll say 2 decimals. We'll be a little bit more specific. And then in cells hit required, we'll say requiring hit 2 cells. So it's going to be going in and having to gather a little bit more data before it plots a value. So then we're also going to go to our shading. We're going to say our high value of plus 30% or adding 30% overall in the trims. We'll make that red, meaning that it's going to be lean and it's going to be adding fuel. On the low value here, we'll put minus 30, and then we'll make this in green, meaning that it's going to be super rich and it's going to be needing fuel taken out. So you'll be seeing this as soon as we plot it in this histogram. Now next we'll have to jump into our column axis. And we need to go to our parameter, and we're going to be adding in here a parameter we've just added to our channels list, mass airflow sensor, and it's going to be in units of frequency. So we'll go up to the top here, we'll type in mass, let it populate our list. We're looking here for the mass airflow sensor in this frequency, not voltage, not mass flow rate, frequency. So we'll double click, say yes, sounds good. And now we can see it's added to our window here. Now we have to do one more step that's super important. We have to jump back into our editor. We're going to go in here into our mass airflow sensor curve, so airflow versus frequency. We can find here that the unit scale on the curve showing us the actual frequency units and looking up the actual airflow amount or air mass amount. We can see we change this. Let's change it to pound per minute. That's what I prefer working with. Now we can find our unit scale here at a given frequency is giving that lookup and that pound per minute of air mass. What we need to do is click on our axes here in the gray. So I'm going to be clicking up here at 2400 in this little breakpoint. I'm going to right click. I'm going to go to column axis and go to copy labels. That's going to allow me to copy this entire labels on the curve here. Now allow us to build this custom histogram. We're going to jump into our scanner. We're going to click into values. We're going to right click, go to paste. Now we can see we have all these values that were previously in here as our header values and our breakpoints are now generated into our channels list here. So we're going to find that this is going to be populated. Now we can see the label here is long-term fuel trim plus short-term fuel trim. Let's just call this math close loop. And we'll have it, give it a custom name. And I'm going to be closing this right now. And let's jump in here and take a look. Now what we're going to find here is that we have this this plot that's going to be a histogram. And we can see we have our breakpoints that are found just as we find here in our table. If we're clicking through, so all the breakpoints are the same. And instead of having a value, it's going to be a blank value here. What that's going to do is plot the long-term and short-term fuel trims. So the average of both of them and the accumulation of both is going to be spitting it out on this histogram. And we're going to be able to take this data and then actually dial in our mass airflow sensor curve. It's actually a really, really simple process. So again, we're going to be taking a look at it right now. So what I'm going to do is I'm going to start scanning, and I'm going to be seeing that all my data here is going to go live. And then we'll see here as soon as I start scanning that it's going to be showing me right where we're at. So we can see in this case, we're at 2,161 Hertz reading on our mass airflow sensor. We can see that the mass airflow sensor state is no fail. Now, if we're going to be going into speed density operation, we're going to see this shows math failed But in this case, it's no fail, indicating that we are running on our mass airflow sensor. Now you can have the dynamic blend here. If we close this real quick, jump back into dynamic, you can have your dynamic blend here set at the stock values and still show this being no fail. So we could be running on this, the map sensor and the MAF sensor together the way that GM has intended and still show this status. But looking at this now, it's going to be indicating to me that I am running on my mass airflow sensor because I've set my dynamic airflow to that lower value. So I know it's switching. So let's go ahead, fire up our engine, and let's take a look at this. So right now we are in open loop. We can see the status of our fuel trim status is showing here dash, dash, dash. That's because it's not doing anything. My engine has not been fired up and none of my trims are active. So we're seeing that's all going to be just sitting here like this. So what I'm going to do is fire up my engine right now. And we're going to let it go ahead and warm up. So the engine is cold. We can see it's actually here at 86 degrees coolant temp. Let's do this. Let's go ahead and stop our scanner. It looks like my VCM scanner here froze up a little bit. Let's go ahead and start scanning again. Now we can see it's generating. Sometimes it does this. I've had the scanner open here for about 20, 30 minutes before I actually started to scan, and we can see it looks like it's freezing up again. So what we'll do is we'll stop this real quick. I'm going to save my channel config as. We'll save this as our Gen 4 idle channels. Actually, we can say Gen 4 MAF tuning. And we'll go up here to our layout and save this also here as GM Gen 4 MAF tuning. So we don't lose our histogram we've created or a custom channels list. Let's save. Let's go ahead and just reboot our VCM scanner because sometimes it does this. I've had a few instances where it freezes up and it causes me some problems here. It's not a big deal. So we have now we've saved those configs. So we've saved our channels and saved our layout. We simply can go here to connected vehicle, give it a second. It's going to go ahead and grab all the information out, and then we're going to go ahead and hit start scanning. And now we can see it's working. So sometimes you're going to have to do a reboot on your VCM scanner. This happens to me every so often, usually when I have my software open for a bit of time and I'm not actually logging. Okay, so what we're finding right now, we jump into our MAF closed loop, and we move into here. We're going to see some values are starting to populate. And what these values are going to represent is the accumulation here of our trims. So we're going to see here, we're in a closed loop normal operation. We've went over that closed loop open loop status. So we looked at this and we see the trims here are going to be trimming and getting us back to our target air fuel. So the target air fuel here at idle and part throttle is 14.5. We can see our wideband here is pretty much operating here at 14.5, 14.7, 14.8. And in fact, we have our switching voltages here plotting on our window. We can see that we have our air fuel reading as well as our MAF pound per minute reading. So if we're trying to evaluate the switching, we could see that in this window. We're going to keep this open because we are going to be evaluating this and actually starting to do some driving on this and populating this table out. It's going to take probably about 3 to 5 minutes of driving to start getting some values plotted in here that I'm going to be able to go in and I'll show you a special copy and paste feature that's going to be speeding up your tuning process greatly. So I'm going to be relying on this just to do my idle and part throttle. We're not going to be using this method right here for this MAF closed loop in the open loop to do our actual wide open throttle tuning. We're going to be looking at a different method in another video. So this is just going to be focusing in on getting your idle and part throttle tuned and set up for your MAF curve. So I want to let this engine warm up just a little bit. We can see it's still at 133. I want to be patient here so I know that it's going to get all up to operating temperature before we start to drive it. So everything we see here is normal operation, normal behavior. We can see our trims are out a little bit here. We're obviously seeing the accumulation as I'm sitting here and we're operating at this 3000 hertz value. Seeing it's showing us we have to take out about 6% in that cell, about 5%. Now we could jump back into our actual file. We jump in here. We could jump in and manually correct this by ourselves. We could hunt the cell points that we're operating at here. If we jump in here real quick, let's take a look. 2850, 3000, 3150, 3300. So these cell points, we could jump back in here to our calibration and we could go start to edit these. We could go grab these values here and we could adjust it by what it's showing us. We can see 7%, 5%, 6%, 6%. So let's just call this taking 6% out. So I could jump into those cell points. In order to do that, to take that 6% out, I would highlight those particular cell points. I would jump in here and I would type 0.94. So multiplying by 0.94 is going to be effectively taking out 6%. If I wanted to add 6%, I would type in here 1.06 and click multiply. So it's pretty easy to use this multiplication factor based on percentages And that's going to be kind of moving from our scanner here back into our file. Now I'm going to refrain from doing that. I'm going to let it drive and operate here for a bit before I make any changes. We're going to be finding here we have this little click box showing on average values. We're taking the average of the values as the data is coming in here at a particular cell point. So the more we drive on this, the more it's going to be averaging, and the better off our data is going to be. Because as we drive, we're going to find that these are going to be changing a little bit. Our trims are constantly changing and moving around, and that's okay, but we don't want to just simply start it up, take a little bit of data for 30 seconds, go and make our changes into our VCM editor. We might find that the next time we flash it, start it up again, it could go in and start to have a little bit different trims. So we want to let it average over, again, a couple minutes of driving and idling before we actually commit any of those changes to our math curve and we do a rewrite. Now, some other things I want to talk about here really quickly when we're talking about the mass airflow sensor here at idle. We're going to be finding the math is showing us right around 1 pound per minute, 0.9 pound per minute. You can even see it's flaring down here to even something like 0.88 pound per minute. We're going to be finding that if you have a stock engine with typical bolt-ons like this, you haven't done any actual changes to injectors or anything with a cam, we're going to be finding that this is going to be pretty average pound per minute reading. As the engine warms up here a little bit, this will drop down just a touch. This is going to be based on the engine RPM you're idling at. I'm idling here at 650. The stock RPM was 550. I bumped it up just a touch. So my pound per minute here is just slightly higher. So anywhere from 0.8 to 1.0 pound per minute is going to be a normal pound per minute reading. If you have a leak from your mass airflow sensor before your throttle body, say your intake is coming off and it's not reading right, you're going to be finding that this is going to change. You're obviously not pulling all of the actual airflow into the engine. You're going to probably see a little bit lower. Now, if you do injectors in your vehicle and you don't program the injector data correct, you're going to be taking up the skewed data here. So let's just assume that as we're looking at this, we see that we have to correct it by 10 or 20% because we put the wrong injector data in. What that's going to make us do is jump into the curve here. We're going to be making those changes and reporting the wrong air mass. So as we're seeing here, the values of hertz, we're going to be finding that our pound per minute is going to be completely skewed and thrown off at that particular same hertz value. So we're going to be finding then that our torque's calculated incorrectly, and there's going to be a whole bunch of other problems with that. So our injector data, we went over that, is super important to nail down right. And as we're referencing things, kind of to keep in the back of your mind, if you have an engine with a stock cam, you're going to find that it's going to be reading anywhere from 0.8 to 1.0 pound per minute at idle. If it's not, then you probably have something wrong with your injector data, or you might have a dirty mass airflow sensor, or you may have some kind of a leak going on. So keep that in mind. Now, when you do a cam, you'll find that it bumps up to anywhere between 1.2 to maybe 1.6 pound per minute. So that's going to be changing how much your air mass sensor is registering here because you're going to be pulling a little bit more air in with that larger cam. So that's going to be something else to keep in mind. Now, when you do a rescale with your injectors, if your injector size grows, if you go from stock injectors to something like 1,000 cc injector, you put all the injector data in and you have a cam and you're doing your tuning and you're dialing in your mass airflow sensor curve here and you're noticing that your mass airflow sensor is registering 2 or 2.5 pound per minute. That is not right. Something is wrong, and most likely it's the injector data. Go back in and check that out. Probably don't have injectors with good data. That's why I recommend Injector Dynamics. It makes your life much, much easier. You're going to find that this calculation here for your actual air mass registration is going to be accurate. So it's, to me, worthwhile to spend the money on the ID injectors because they have the proper data and it keeps your mass airflow sensor in line here with what it's supposed to be reading. So that's just going to be one tip I'm going to give you. But now we have our engine up to temp. It's at 174. So let's start to drive this. What I'm going to do is just actually go in and start doing my part throttle driving. So I'm not going to go in full throttle. I'm just going to be operating it. I'm going to be keeping it under our power enrichment. Now, we briefly touched on power enrichment. We're going to be covering that in a video coming up here in the course. But just to briefly kind of cover this, let's jump in here to fuel, jump in here to power enrich. Now, our power enrichment is going to be where we command a richer air fuel. So we'll go over that so it makes more sense. But we can find here in the throttle, we're going to be seeing here that our throttle threshold, as long as I'm under this particular threshold, so 50% throttle here at 3,000, as long as I'm under that, I'm going to be operating in closed loop, not running in this power enrichment mode. So I'm going to just simply drive it, and I'm going to be finding here that my air fuel command, it should be staying here at 14.5, 14.6 air fuel, and it's going to allow me to just build out this table. So again, We're on the mass airflow, our dynamic airflow has been disabled, so I'm focusing only on MAF, and we're going to build out this histogram. When we go and start to drive the vehicle, give me about 3 to 5 minutes, come back, we're going to check out the data, and I'm going to be telling you what to do and what the next step is here that in order to go populate and recalibrate your mass airflow sensor curve. Okay, so it just took a drive for a few minutes, and we can see as I was driving around, it was populating all of our data here for our trims. So we're taking a look here, we can find as I'm driving around, it's showing a bunch of negative values here, all the way up to here at about 7,350 hertz. So this is the operation as I was driving around, again, populating this long-term data over about 5 minutes of driving time. We can see our scanner still running here. So let's go ahead and stop this. I'm also going to be shutting off my vehicle real quick so we can go ahead and talk about this, and then we can see what we need to do with this information. Now, the first thing we want to do is evaluate this actual data log here. Let's pan back into areas where I'm actually driving. We can find here that this is about a portion of area where we're driving. We can see that our O2 switching voltage here is switching very quickly. We also can see that the engine RPM here is around 1500 RPM. Let's take a look at what our air fuel is doing here. Now, we need to make sure that when we're taking a look at the actual data here and the evaluation of the closed loop performance, we want to make sure that our air fuel here is going to be hitting what the target air fuel is requesting. And in this case, it's going to be 14.5. So if we're taking a look through our data log and we're kind of panning through, we can see as we're driving here, our O2 trims are switching. We can see that we have the activity out of our O2 sensors. We can find here that our air mass registration is around 8.61 pound per minute. And then we can find here that our air fuel is showing us 14.54, and we can see our requested here is 14.56. So in the red line here is our actual air fuel. If we're kind of panning across and watching the data here, it's 14.5, 14.8, 14.3, 14.4. So this is actually trimming right exactly where we want it to be, and we can find that our actual fuel trims are doing their job. So if we take a look at some other operation zones, we can find that that's going to be happening here. That was at 1800 RPM. If we take a look, some other RPM ranges as I'm driving, we got the 1600 RPM. Let's take a little bit higher operation in our scale here. We can find right here, we're at 11.2 pound per minute worth of airflow, around 1700 RPM. And we can see that our air fuel's hitting here 15. It looks like it went a little bit leaner right there. Nothing tremendous. And as we drive here, we continue on and we can see, so the average trend, the average air fuel here, as we're looking at this, is hitting what we're asking it for pretty consistently. So this is going to be having our O2 switching happen correctly, and it's going to be going in and having our actual switching voltages correct. So we don't need to adjust anything, even though I've installed long tube headers on this. So that's something to note. Now, if you wanted to have a little bit leaner air fuel here, you might go in, even though your target is at 14.56, you could go into your switching voltages and try to experiment by moving them up or down here. Let's jump into our fuel, into oxygen sensors. You could jump in here and try to experiment by adding another 50 or 100 millivolts, either adding or subtracting, and experimenting with that at that particular airflow. So remember here, just a quick refresher, if we're tracing through, if we're showing here 7 pound per minute worth of airflow, to figure out where you'd be at in your switching table, you'd have to go to mode versus airflow, and we can look here around 7 pound per minute, so 6.9. We're operating here at zone 50. That would make us jump into our table here, and then take a look at around our zone 50. So right around here, 48 to 56. These are the numbers that we would go after if we're interested in that particular area of performance, or if you're noticing maybe your air fuel is doing something odd under cruising and not under idle. So just kind of break that down. But I wanted to verify that first before I went in and applied any of these changes based on what our short and long-term data is going and doing. Because if we're shooting for this target of 14.5 and we were way lean or way rich, when we were at 14.0 as we're driving around, yes, our trims are trimming out the mixture, but it's trimming it to the wrong air fuel. And we're not going to know that unless we have our wideband here and do our chart versus time and overlay. So this looks good. I'm going to be trusting my trims. I'm going to be now applying these back into my mass airflow sensor curve. So what I am going to do here is I'm going to do a special copy and paste feature. Now what we can find here at the lower scale of the table from 0 up here to about 22,550, they didn't collect any data. We don't simply operate that low, but obviously above this we have, and we've seen here that we're generating this histogram chart. So what we have to do is copy this entire table here. It takes a little bit. We have to be patient while we go here and scroll all the way across. So let's just be patient. We're going to be copying this and then using a paste special function into our mass airflow sensor curve when we take a look at this. And then we'll be able to dial this in a little bit quicker Let's just be patient here. Again, it takes a little bit to highlight the entire histogram table here. And we'll be able to simply make our changes based on what it's already collected for data. So we don't need to really do anything other than go and take a drive and pay attention to our trim data. But the most important thing, again, is making sure your wideband is going to be lining up and making sure the trims are going to be trimming it, even though you're trimming it at the commanded airfield, that you're trimming it correctly and it's going to be hitting the airfield you actually want. So now that I've went ahead and I've highlighted, let's go to copy. Then we're going to move into our VCM scanner. We're going to jump in here to airflow, into MAF calibration, airflow versus frequency. We're going to highlight the entire table here. This is going to go much quicker. We can obviously just go right across. Then we're going to go in here, we're going to right click, and we're going to go here to paste special. Then we're going to go to multiply by percent. So we've collected a percentage in the histogram, and we want to multiply our MAF curve by that percent. So we don't need to make any manual calculations. Now, even though we're importing this data, we're still going to probably have to do some blending of this data into the MAF curve because it's just simply not going to be that easy. We've only collected the range of operation here. Again, from this band or this portion here from 2700 hertz all the way up here to 7350 hertz. So we're missing the data above and below that. We're gonna have to go and populate some of that so it's not going to be ruining our mass airflow curve. So again, we're going to go right click here. We're going to go to paste special and do multiply by percent. And now we're going to find that this has updated our table. But we need to jump into our 2D curve and take a look at this because it's probably not going to be smooth. And we can see right here, in fact, it's caused a step in the calibration curve. So right around here, which is at point about 7500 hertz, we're going to find that the values here are higher than this now. Let's turn that down manually because we don't want to leave it like that. So if we jump in here, we should be able to very clearly spot the point where we've stopped. Right here is where it stopped. And we can see then above this, we're going to have to turn the values down here. We're going to find that we need to alter that. Let's just take out 0.9 or 10% and multiply, and then go back and check and make sure that our curve is smooth. Now it looks pretty smooth. So I'm happy with that. I'm going to be writing this now to my PCM. So I'm going to write it, and then we're going to go and try this one more time, do another run through and see what that's going to look like. Usually it takes about 3 to 4 run throughs of driving and collecting the data and moving from that copy and paste feature to build out your mass airflow sensor curve at idle and part throttle. And once you've done that, it's all set up in tune, and then we're ready to take a look at our full throttle. We're going to be looking at in a separate video and going in and doing that tuning process. But we're not going to be based